This is the video introduction to Experiment 6 for Chemistry 300, oxalate determination by redox titration. Your goal is to determine the concentration, percent by mass, of oxalate in an unknown solid sample. The method that you're going to use is a redox titration using the permanganate ion as your titrant. You can see the reaction of interest here. This is a redox reaction between the permanganate ion and the oxalate ion. Obviously this is not balanced. It's in the balanced form in your lab manual, but I would suggest you balance it by yourself starting from this equation. First of all for some practice, and second of all to see why the reaction conditions are the way they are. The permanganate ion is going to serve as our indicator in this reaction because the permanganate ion has a deep purple color while the reduced form, the manganese ion, has no color. You're going to need to weigh out some sodium oxalate into your titration flask to begin your standardization. You're going to need to weigh this out because we're going to do this titration in large 500 milliliter Erlenmeyer flasks, and so they will overload the capacity of the balance. So you must use weighing out for this experiment. Once you've got your sodium oxalate weighed out, you're going to dissolve it in 200 milliliters of water, and then you're going to add 10 milliliters of 1:1 sulfuric acid and water. This is roughly 9 molar sulfuric acid. So it's important that you are careful when handling it. When you balance your redox reaction, you're going to see why we're adding so much of such a concentrated acid to each titration flask. Once you add the acid and the sodium oxalate is completely dissolved, you're going to put the Erlenmeyer flask on a hot plate for 7 to 10 minutes. And the hot plates are going to be set for you. You don't need to adjust the temperature setting, and you also don't need a thermometer. If you leave the hot plates where they are and put the flask on them for about 7 minutes, they will be at the correct temperature. You'll know they're at the correct temperature because you'll see some condensation on the neck of the flask. The top is going to be cool to the touch and you can pick it up without gloves, but the bottom will be warm, about 60 degrees C, and so that will be the correct temperature to do the titration at. You only want to have one flask at a time on the hot plate so that the other ones aren't cooling on your bench while you titrate the first one. So what you should do is when the first one's ready to come off, take it off, put your next one on at the same time, and then have it heating up while you titrate the previous flask. Also, these all look the same, so make sure that each flask is labeled with your name so that you can find yours. This is what your titrant looks like, potassium permanganate. It has this very deep purple color, and so this is one of these cases where you can't read the bottom of the meniscus. You're going to need to read the top. Alright, this is a perfectly valid way to read a burette. You just have to do it the same way every time. This is what your flask is going to look like after the addition of less than 1 milliliter of titrant. You get this very deep purple color, and it looks like you've missed the end point. You have not. The thing about this reaction is it's self-catalyzed by the manganese ion, which is a product. So at the beginning of the titration, you have no product, so there's nothing to catalyze the reaction, so the rate is slow. Even though the flask has been heated, it doesn't raise the rate high enough to have this go away immediately. So what you should do is add about half a milliliter, stop, swirl it for quite a while until this color goes away, and then proceed as normal. So this is after that same half milliliter addition, maybe after a minute, maybe a little less than a minute even. After this point, the titration will proceed just like the other ones have, where you see a little bit of pink when your titrant goes into the solution, and then as you swirl it goes away right away. Since the permanganate ion is so brightly colored, it's going to be really easy to get a very faint pink as your endpoint. Right, you're going to be very close to the endpoint and you'll see a color show up. So what you're looking for is this very faint pink, and then here it is with a piece of white paper held behind it. This is your endpoint. If you go farther than this, you're going to get that same bright purple color again that you got at the beginning. So this is maybe 1 milliliter past the endpoint. Your data analysis is going to go the same way it has for the last few experiments. For your standardization, you're going to figure out how many moles of oxalate you added to the titration flask as solid sodium oxalate. You're going to use your balanced redox equation to find the number of moles of potassium permanganate delivered with the burette. and then you'll use the volume that you delivered to find the molarity of your potassium permanganate titrant. For the unknown determination, you're going to add some permanganate with your burette, so you're going to know the volume, you'll know the concentration, calculate the number of moles. Then you'll use the redox equation to find the number of moles of oxalate in the flask, convert that to grams of oxalate, and then you'll use the mass, not volume, of unknown used to find the percent by mass of the oxalate ion in the unknown.